Hello, my name is Long Lai. Today I'm going to be doing a presentation on radioactive and other chemicals in groundwater. Let's first briefly talk about what is groundwater, where does it come from, how is it even formed? And the best way to explain that is through the hydrologic cycle or the water cycle. Now wrap your mind around this. All the water that is currently on Earth is all the water that ever has been. It's just been through the cycle and it's been through different phases, it's been through different forms, but it's the fresh water that you see is just it's the same, the molecules are the same water that has been here a million years ago. But with groundwater, in the cycle, how groundwater is formed is first from rain, from precipitation. When it rains, the water eventually it permeates the ground or through a process called percolation, where it percolates through the ground and gravity pulls the water downwards. And as it goes downwards, moving through all these different type of rocks, different gravels, and it continues going down until it becomes saturated and creates the water table, and eventually becomes part of the groundwater, which later we'll find out how important it is that groundwater is the way it is for and why we rely on it. So what's the deal with groundwater? Why should you be concerned about it, and how important is it really? Well, according to the National Groundwater Association, groundwater supplies drinking water for a little more than half the total US population, and 99% of that is rural population. In addition, 64% of groundwater is used as irrigation to grow our crops. As you can see in the chart below, um, groundwater is used for livestock, is used for different domestic uses. So it is important also for the recharging of our lakes, our rivers, and our natural wetlands. So yeah, it's kind of a big deal. Now let's talk about how our groundwater can be contaminated. And contamination is any repercussions or products of human activities that introduces unwanted chemicals into our groundwater, thus making it toxic or unsafe for humans or wildlife consumption. And these materials can come from any everyday or agricultural products. So even liquid waste from our septic system that is leaking or faulty, it can get into our groundwater, which is our drinking water. And because these groundwater is dependent on plant life and animal life, it can destroy ecosystems, and ecosystems are very vital to human life here on Earth. Here I provided a image from the Groundwater Foundation that illustrates different ways where our groundwater can be contaminated. And as you can see, it's everyday things, like even the gas station where it has underground storage tanks that could be leaking for who knows how long, and who knows how much into our groundwater, or um, hazardous waste that are just being dumped and improperly, and there's just running off into our rivers. So I'm hoping that this illustration brings awareness to what can you do during your everyday life to minimize contamination of groundwater. Now we turn our attention to the types of contaminants, or the main types of contaminants that we see often. The first we're going to talk about is nitrate. And if you have ever lived somewhere where it relies on a water well, then you would know that your local health agency normally requires the well to be tested for nitrate. And the reason why is that nitrate in high concentration does have negative effects on human health and wildlife, especially concerning to infant and pregnant women. Nitrate enters our groundwater through by runoffs after being exposed to certain waste products, certain chemicals, fertilizers, where it carries these chemicals as runoffs into our rivers and percolating into our ground and eventually ending up in our groundwater. Um, and infants under 6 months of age, pregnant women, and certain adults are susceptible to a rare sickness that are caused by exposure to nitrates. It causes what's called blue baby syndrome, where it turns the skin blue. It causes dizziness, headaches, weakness, and trouble breathing. Another source of contamination is from pharmaceutical and personal care products. Now, you may be wondering how your household items are getting into the groundwater. And there's many ways, but one of the examples is that flushing of unneeded pharmaceuticals. So people are flushing their medication down the toilet, and this gets into the groundwater eventually. Traces of medication, these pharmaceutical ingredients are getting into our waters or groundwater. Another is if you have a house that uses a private septic system and you're not maintaining it properly, you don't know and that it's failing, um, that is leaching saltless liquid waste into the ground. It's until it's too late and you see it surfacing. That's when it's too late. So in every rural area, your local health agency should have regulations of how often your septic system should be serviced by a professional, and owners of those septic systems should adhere by that. Um, a study that was done just to show the importance of this is that study that was done by the U.S. Geological Survey in 2002, where they examined 139 streams in different states. They found that 80% of those streams had detectable quantities of pharmaceutical and personal care products. So by us understanding and recognizing our actions, we can minimize the contamination of our groundwater. Speaking of rural septic systems, we're now going to turn our attention to on-site wastewater treatment systems. And these are septic systems that are put in place mostly in rural areas where facilities or homes cannot be connected to city sewer lines. And how these systems work is that it pretty much it connects to your home, and usually there's some sort of tank or pump that pumps the effluent into a field or a leach field where it just gets absorbed into the soil. There's different complexities to these systems. Some uses a very complicated high-tech pump, or some just use gravity by alone. Um, for these systems, the owners of these systems really must stay vigilant, and they must really adhere to the regulations set forth by their local health agency as to how often they need to have it serviced by a professional. So, and that's how important this is. A professional needs to come out to take a look at it, because you never know where your system is faulting. A lot of this is problematic with older systems. The newer system nowadays have computer panels that will tell people or tell the servicers what the problem is. It's all electronic. So yeah, but still, these it's best if you have this type of system. It's best to consult with your local health agency as to what type of system, whether your type of system, and how often it needs to be serviced. Next, we turn our attention to radioactive contaminants. And when it comes to radiation, ionizing radiation, this can cause detrimental biological effects. It can alter genetic coding. It can cause mutations. It can um, cause uncontrolled cell growth, which increases cancer risk. A lot of the radioactive contaminants in the water takes the form of radionuclides, which includes isotopes of uranium, radium, radon, and others. These substances are present and can enter the water supply via natural occurring or human activities. So let's talk about the two forms of radionuclides. One is the natural occurring radioactive materials, which what this means is that it's naturally occurring within the Earth's crust. It's from our atmosphere, it's from cosmic rays, or it's just from the in Earth's crust there's decaying of radioactive elements, and this is giving a small exposure into our groundwater. The other is man-made. And man-made radiological material can come from oil or gas productions. It can come from metal mining and smelting. It can come from the coal industries through mining and combustion, through phosphate fertilizers. And also the building industries can introduce some form of radiological material. Next, we'll talk about there are three different types of exposures to radioactive contaminants. The first ones are alpha emitters, and these are in rocks and soil, which can get into the groundwater this way. However, these particles cannot penetrate the skin and clothes very well. They're typically ingested and breathed in as radon. The next ones are beta photoemitters. These can be found in surface water around nuclear plants, industries and medical facilities that uses nuclear medication, and if they're not disposing of these radioactive waste correctly, it gets into the soil and then eventually into the groundwater. An example is lead 210, which is a radioactive form of metal that has decayed from uranium 238. Beta photoemitters can also be found in high phosphate fertilizers, which is the cancer-causing components of cigarettes. The next is exposure to gamma rays. Gamma rays are normally or the same as the ones generated by an event such as supernova, which is star death. It's a supernova explosion, and this can be found naturally occurring particles in the environment because of this process. And all Earth life are exposed to a low dose, but in heavy doses extremely dangerous. And these are usually just found in medicine to be used as tracers or cancer treatment or to sterilize equipment. In summary, we learned that groundwater is extremely important. Groundwater is used for drinking, is used for growing food, is used to maintain our current lifestyles. And so protecting it and keeping it clean, minimizing contamination should be prioritized. In addition, it's also very important to animal life. It's important to plant life. These ecosystems are important to maintain balance as it does affect human life. As we learn that through human activities, we are introducing nuclear waste through improper disposal of nuclear waste through nuclear mining and through weapon testing. We're introducing radiation that could be detrimental to life here on Earth by contaminating our groundwater. And if we recognize and make the necessary proactive actions, we can start taking steps to protecting our groundwater and keeping it clean and keeping it accessible for generations to come.